Welcome to the Modern Software Engineering channel. I'm here today with Emily Bache, and we're going to talk about one big question. And today's question is, should test-driven development be more widely used? Emily, should test-driven development be more widely used?
Yes, I think it should.
I agree. I think it should as well. So what are we done? I think we've got more to say.
Definitely. So let's talk about what TDD actually is, because there are a lot of misconceptions and people who argue against TDD from a basis of describing something that isn't TDD. So I think that's the first thing to establish what we mean by that. And I think I want to talk about Kent Beck's canon TDD. He's got a post about this, that basically TDD involves first thinking about the problem you're going to solve and writing a test list, breaking the problem into small pieces. And each of the items on that list ultimately is probably going to turn into a test case. And you do them one at a time. You write the test. You get it to see it fail. It's got an assertion in that test. You write just enough code to make that test pass. When you're doing that, you can commit any design sins that you like. You can duplicate code or just write everything in one function or whatever. And then you have the refactor step. Once the tests are green and passing, all of the tests should now be passing. Then you refactor. And then you go back to your test list and you pick another test off the list. And of course, while you're doing this, at any point, you can add tests to the list or you can cross tests off. So that list is dynamic and gets updated. And the idea of this is that you always are working in the context of either all the tests are passing or you've got one failing test. And you always know which of those states you're in. And at the end, when you've run out of tests on your list, you've got a good regression suite covering the functionality that you've just built. So I think that's really what we mean when we talk about TDD.
I think that's I think it's important to get that kind of nice statement of what it is that we're talking about in place. And the other thing that I think is important is that one of the critiques that I've heard of test-driven development is that it stops you being able to design. And I think nothing could be further from the truth. Part of your description, I think that there are two key focuses on design just in that short description that you've just made. At the point at which we're writing a test, we are consciously really designing the external view of our code from the perspective of a consumer of our code to be nice, to be easy to interact with. So we're designing the interface to the code that we're about to write is really what we're doing when we're writing a test. And then we implement the code. We're not really designing there. We're just trying to be tactical and just get something working in place quickly and efficiently so that we minimize the distance of insecurity when we've got a failing test. So we're going to quickly get to a passing test. And then the next stage of design is really the refactoring, where now we're designing the internal implementation while we've got a passing test that tells us that everything that we're doing is still working. So I think that it's this enormously powerful tool that drives us to design better code from the outside because we build better factored code because it must be in order to be testable. And it gives us a more stable platform for coming up with better implementation detail because we know that it works because it passes all of our tests. So I really like your description as a starting point to get us going. But that sense of design is a huge part of the value of test-driven development to me.
Yeah, absolutely. I mean, it's got these two great outcomes from it. The tests themselves, the regression tests that should help you to understand. But as tests go, unit tests often don't really prove very much. I think there's a lot of testers out there in particular who'd be like, you can't judge the quality of a product purely on the unit tests. I mean, there's got to be more testing involved to actually show that the thing works. But it's a very good start because it shows that the code does what you think it should do. And then the other outcome of TDD that's so important, as you say, is the effect it has on your design. Because there's this, Michael Feathers talks about this deep relationship between testability and good design.
Yeah.
And it's kind of flows from the fact that you're thinking about the client all the time. You're using the code in the test.
Yeah, you have to be pretty stupid to write a design code that's hard to test. Because you're starting by writing a test. So you've got this automatic pressure on you. One has this automatic pressure on oneself to design code that's easier to test because otherwise we're stupid. And so it gives us this forcing function that drives us to prefer testable code. And testable code is, to my mind, pretty much by definition, better code. It's higher quality code. It's more modular, it's more cohesive, better separation concerns, better lines of abstraction, looser coupling, all of those things. Because without those things, without any one of those things, it's not quite as testable as it would otherwise be.
Yeah, and it's a skilled activity, and it takes a little while to learn it, to actually work this way. And a lot of people, so maybe we should talk about some of those objections that people have, basically, about, and it one of them, I think, basically stems from people not being good enough at design to separate their concerns in the way that you need to in order to make the code testable. I don't know how to teach design other than to teach people TDD, I guess. The other thing people say is that they don't know how to test it until they've seen the implementation. They can't imagine the shape of the code until they've actually written it. And that's always one that I've kind of until I had an experience just a few weeks ago that made me think about that again, actually, because it's kind of true that you want to write the test as the user of the code, and for that you don't need to know the implementation of it. You just need to know the interface that it should have. But I was coding with a group a few weeks ago, and we were doing TDD, and I didn't know their code base very well. I was coming in to coach, and they didn't know TDD very well. So we were kind of I was trying to help them with the TDD. They were obviously experts in their code. And we needed to implement a feature. And one of the outcomes that was important, that was when we adjusted the state of this domain object, a message should appear on a queue somewhere else to say that this change had happened. So I was like, okay, well, the externally observable thing here is that we have a queue with a message on it. So let's write a test that checks that message is there on that queue. And we were getting into like, what the format of the message, what kind of object is it, what can we create a test double for the queue? And the test was getting quite difficult. And then we got the test done, and then we went to look at how to implement it, and realized that there was a whole section of code that I had no idea about, that was going to do the message creation and putting it on the queue. And all our bit of code needed to do was just like call a function with a few arguments. We'd done all this vast setup, and if I'd actually spent some time to really look at the implementation and think about how to do it, there was a much easier way to test it and drive that.
Yeah.
You do need to understand the context that you're writing tests in, I guess.
I think you do. So I was not one of the inventors of, or the initiators of behavior-driven development, but I was there at the start, and I was talking to the people that were coming up with the ideas, and was involved in writing about it at the start. And it started out very differently to where it's largely interpreted now. It started out as a better way to teach test-driven development, kind of for that reason. So, to my mind anyway. So I think this is important because, as you said, TDD is kind of a broad spectrum. And mostly when we talk about TDD, I think we're talking about fine-grained unit test level development. But I think it goes further than that. And there are more parts to it than that, different types of tests that fall under the TDD canon, really. But certainly at that fine-grained level, but also everywhere else. What we really want from those tests is we like tests that express what we'd like the code to do without saying anything at all about how we achieve that, so that we've now got the freedom to determine how we're going to achieve it. So we can do that separately from specifying what we want it to do. And by focusing on our tests on getting the behavior right, it allows us to think about those two separate parts of the problem of writing software. What is it that I want to achieve? I can write a test that says that. And then how am I going to achieve it? I can worry about the detail of how that's going to be achieved. And it's only in the second one of those where you really care about the implementation detail. What you wanted to achieve should be expressed by the outside picture. And in your case, in your example, you wanted to generate an event of some kind or call a function of some kind that resulted in a message. You weren't really, the test doesn't need to know about that. All it needed was the fact that as a result, some signal was sent that would eventually result in a message. And that kind of leads, as you were describing before, one of the things that goes through my head when I think about test-driven development is it's kind of analogous to the fine-grained TDD is kind of analogous to the rules of algebra. If you're solving a problem in maths and you're using algebra as a tool, you need to follow the rules of algebra. You need to do the right things to expand brackets or to move variables around in an expression and all of those kinds of things. But that's not the only game. There's the higher level picture of whether you're actually solving the problem. So there's the kind of the mechanism, which is the kind of fine-grained TDD that we're talking about with unit testing. So, one of the rules is that I'm going to, given some system in a certain state, when I act on it in some way, some result occurs. So how do I measure that result? What's the closest I can get to the piece of code that I'm writing now that's going to tell me that result? So that's one of my rules of algebra for TDD. And then, you put this in the broader context of, does it plug into the messaging system that, actually formats the message and sends it and all those kinds of things? And I think it's one of the reasons why I talk about it so much about engineering. I'm talking too much now, but it's one of the reasons why I talk about this as engineering, because I think it, as we've already described, it drives us to doing a better job when we start to follow these reasons. And I think that's deeply one of the reasons why I think TDD should be more widely used than it is.
Yeah, you said a lot there. Yeah.
Sorry.
But this thing about TDD making you focus on the spec, the observable outcomes, what should the system do? That is absolutely what I was trying to do. I guess I was just kicking myself afterwards that I'd missed that actually I could have written a much more simpler test for this bit in this situation. And that would have been more useful for driving the design, just because I didn't know the code and I didn't know all this existing code was there. And actually they didn't either. It was an area of the code. And if we just spent some time looking. So I think this is why people want to know the shape of the implementation before they write the test, because then they'll maybe find an easier way to test it. But like you say, that then maybe we'd miss the whole aspect of specifying it.
I must confess, I don't know whether it's just the way that my head works. I tend to think of that the other way around. I tend to think about, if I'm writing the test, what's the easiest way that I can measure this result that I want to achieve? And I let my design choices be driven by that. So if I'm writing a piece of code that's doing something and results in an event being sent, I automatically want to separate the concerns of sending the event from generating the result. So I'm going to be designing to be able to just measure the result in that piece of code, and then measuring the sending the message in another piece of code somewhere else, is the way that my head goes, which is, I think he's deeply informed by my desire for testability and test-driven development, but drives me in the right way of what I would think to be a better factored design, as well as a more testable one.
Yeah, you're right. Separation of concerns. I should have thought of that would be a better way to think about it. Yeah, so it doesn't always go totally smoothly when you're doing TDD.
Absolutely not. And the feedback that we get when it screws up is part of the value.
Yeah. Yeah, so I think I really value TDD as a discipline of making me think about the way I build software in a different way, in small steps. And I think that's something people don't see as obvious when they think about TDD. When you ask them to describe TDD, they say, well, you write the test first. But it's about the small steps and forcing you to decompose the problem and see those green tests every few minutes, so that you're actually making progress while you're developing. So when I'm doing TDD at the moment, it's really about knowing whether I expect the test to be passing at the moment, whether I'm refactoring, or whether I'm working on the next increment, and how long is it since the test last passed. That's...
Yeah, those small steps with confidence. It's the feeling safe while you're making the small steps, isn't it? Because you get this constant stream of feedback after every small change. I was watching some of your stuff about refactoring recently, and it was very noticeable the way in which you were making progress in tiny little steps, and after each little step you were running the tests, and that's that's important. It's what this gives us, this sense of confidence of being able to proceed safely, and it's got this side pressure of driving us towards better design. I think something that you said earlier, sorry if I could just come back to that, is that I don't really know a better way of teaching design than teaching people TDD either. And I think, if we wanted to answer this question, should TDD be more widely used? Yes, because it would teach people to be better software designers. And that's something that we don't talk about enough and don't do enough in our industry.
Yeah, there's an awful lot of code out there that I look at and I'm like, goodness me, this is so procedural. There is no objects, there's no responsibilities, there's no separation of concerns. And this code is really hard to change safely. And it would be so much better if people had actually built it with tests from the start, because that would have forced it to happen. So yeah, it should be used more widely.
Good.
Okay. We've got this so much agreement about this. Can we talk about something maybe we agree less about, because I want to
Sure.
talk about approval testing.
Okay.
Because I think we talked about this before a little bit, and it's a technique that's very useful in legacy code. You can use an approval testing framework to do characterization testing, where you basically pin down the behavior of legacy code. And I use it for that a lot. But you can also use approval tests to drive TDD. And it's not obvious because, of course, the thing with an approval test is that the assertion is not defined up front. So it's not canon TDD. You define the tests just as the arrange and the act, or the given and the when. And then the actual part that checks what happens isn't defined until the implementation is finished, or not finished, or at least better. So you get a TDD process where you get a failing test, but you just get this diff to say, well, this is what you're actually getting when you ran the test. Is that what you wanted? So it's not canon TDD where you define up front what you expect. But I find that it works because I guess maybe because I'm used to the rhythm of TDD, you can still get this very nice feedback cycle going where you're making small steps and the output that you're seeing in the diff is looking better and better. And each time you approve it, you've got green and you can refactor. But it's a different kind of TDD because in classic TDD, you get this test list and you're kind of crossing things off and you're getting more and more tests. In an approval test, you quite often would just work with one test and iterate on that one until it looks good, basically. So I what do you think? Is I've been trying to convince you here. This is TDD?
No, I'm afraid I still disagree. So I am very, very grateful to you for introducing me to approval tests in the first place many years ago. And I didn't get it at first, but now I do, and I find them extremely valuable, and I recommend them almost everywhere for characterization testing. But I confess that I think that you're skipping over an important part of the conversation in your description there. So I was talking to Dave Thomas a little while ago, and he said he doesn't always write tests anymore. And that's because he's done so much TDD that TDD has taught him how to design, so he can design pretty well without the tests. And I think you're doing the same thing. I think that absolutely, if that's working for you, I can't critique it. It's working for you. It's good. But for me, when I'm exploring, the problem that I have is that an approval test is always based on my solution. It's based on the output from my solution. So sure, I can look at the results of the output from my solution, but I could do that in other ways other than approval test and decide whether I like them or not. And that might be useful input, but it doesn't seem like it's the same thing as TDD to me. It's not driving me to design in a certain way. It's not really verifying that I got what I wanted. It's just verifying that I'm still getting what I wanted. And I think that seems like a different thing to me.
Yeah. So I think there's maybe something in what you say because I already know how to design testable code. I don't miss the design pressure from the tests. There is some. Yeah. But okay. So then the question is, can you learn to be a good designer without doing it through learning TDD? I mean, you probably can, but it's a very good way to learn to be a better software designer.
I think that you can, but I also think that there are things that you will learn from TDD that you won't learn without it that are valuable. I've had the privilege of teaching some extremely good programmers TDD. One of them in particular is my friend Martin Thompson. You know Martin. And Martin, okay. So Martin is one of the best programmers in the world. I think anybody that's ever come close to him would agree with that. He's a fantastic programmer, and I taught him to do TDD, and he and I both think that he's even better now as a result of that. So I think that even for wonderfully talented programmers, TDD is still a powerful tool that will help you to improve, to get better insights to the quality of your designs. It sends you, we were talking beforehand, it sends you signals. It's the best tool for giving you feedback on the quality of your design that I know. And it will do that early in the process, because as I'm writing a test, I'll start to think, you were writing your test with the messaging queue and thinking, I don't like this test, this is too complicated, this is getting hard. That was the test screaming at you, change the design. That's what it was doing. It was telling you to stop and think about the design, So now I'm going to come to it, and sure, all of us might go too far down that road, but we're getting the signals, we're getting the feedback that now's the time to stop and think, and to clean up the design so I don't have this problem. How do I avoid this problem?
Yeah, no, that's a really powerful story that your friend thought he was a better programmer once he'd learnt TDD, even though he was pretty good to start with.
Yeah, just to be clear, Martin's better than pretty good.
Yeah, the other thing I hear people saying is that they don't think it's important to write the test first, that they will go and write the implementation, they write the test afterwards, and then just change something to make sure it fails. So they've seen it fail, so it works as a regression test. So that's the argument I've heard, and I can see you smiling. If you didn't use the test to get that feedback while you were designing it, then
you lose much more than half the value, and it's worse than that, because as well as not gaining half the value, you lose half the value of the test, because now the test that you've written after the fact is tightly coupled to the implementation that you choose to make. And so all unit testing is better than no unit testing, but it's not even close to as good as first test-driven development. So unit testing after the fact leads to tests and code deeply entwined and concreted together, so that over time, projects that work like that concrete together until they're almost impossible to change, because if you change the code, it fails the test. If you change the test, it's not testing the code properly anymore, and so you can't change anything. And I've seen that so many times. I can remember when I first started doing TDD, we used to have debates about whether it test first or not. Now I think it's a dumb question, because there's no argument. Test first is test driven, and test after is not. So it's not test driven development unless you write the test first, but in my book anyway.
And you cut yourself off from the opportunity to listen to the feedback in the test, that design feedback that you get.
Absolutely.
So I think any approach to try and teach developers test-driven development that doesn't involve writing the test first is kind of doomed to fail. So TDD is hard to learn though, and people are, I think just because we've been taught our entire careers to think about how to implement a thing as being the core of the problem, we don't naturally always think about how to test the thing as actually the first step.
Yes, and not just how to test it, but how to specify what we want. We often don't think clearly enough about what it is that we're aiming to achieve. We start off kind of doing a random walk around our code and writing stuff without really being clear about what it is that we're trying to achieve. One of the disciplines that I value very strongly that I've learned from test-driven development is being much clearer about what it is that I want to achieve with this change, this bit of code, whatever it might be. And that seems important to me.
Yeah, and what is the current focus? What is the slice of this functionality we're doing at the moment? What are the edge cases we're ignoring at the moment because they're on our list, but we're just going to try and get this part working? So one of the things I found useful when teaching people TDD is getting people to express first in the test list, what is the purpose of this test? And then in the actual code, when they come to write that test, to declare it and write in code comments what is going to happen in the assertion part. Start with the assertion. What is going to be true after this? And then get working backwards. What is happening in the acts part? What is happening in the range part? And write that just in code comments before you start to fill in the code, because it forces you to just really think through the whole design of the test before you come to write it. So I think that's my bit of advice, basically. If you're struggling with TDD, just try and write the test in comments first.
Yeah, and backwards.
Yeah.
Yeah, write it backwards in comments. Absolutely. Yeah, I that's a piece of advice in my TDD training that I offer. Is start with the assertion, because you know what it is that you want to happen. Start with the assertion, then say what triggers the assertion, and then say what states the system got to be in order to be able to achieve the assertion. And the test almost writes itself.
Yeah, I think we've both spent a long time trying to teach people TDD, and it is, yeah, there's various things like that help you to get the idea. And it takes some time. I mean, what is your experience? How long does it take people to learn TDD?
I think that there are two levels at which I'd answer the question. So the first one is that the skills of TDD, I don't think they're that hard. I think you can learn the core skills of TDD probably in a couple of weeks. But The hard part, the thing that trips everybody up, is that test-driven development, as we've been discussing, puts you face to face with how bad your design skills are. And being good at design is the work of a lifetime.
Yeah.
And so you never really perfect that. So, we're all learning about how to become better designers. So that goes on forever. And that's the really difficult part, it seems to me. So when I teach people TDD, I tend to so my training course on TDD is called Talks About It in Terms of Design. TDD as a tool for designing software. And I think that's important because that's what we're really learning when we're doing TDD. We're learning how to be better at design, because the things that make TDD hard are always about design. Always. It's never anything else. It's how we choose to organize the code that makes it hard. So we can fix it by being better at how we choose to organize the code. And that's one of the other reasons why TDD should be so much more widely used.
Right. And if it were more widely used, we'd get better design software that was more flexible and cheaper to change and update and follow the needs of the business more closely and more quickly. And that is what I think everyone wants.
Yeah.
So that is why TDD should be more widely used.
At which point, that's probably a good place for us to stop.
Yeah. It was great to chat with you about this topic, Dave. We're in so much agreement here, and we've got
we are.
Different backgrounds, but we've come to a very similar conclusion about this topic.
I think so. So to everybody watching, thank you very much for watching. And if you enjoyed the content today, do hit subscribe if you're not already, and hit like as well to promote the channel. Thank you, and bye-bye.